Good morning. Actually, it's a good evening. It looks like it. I'm up in the northern part of Canada watching the northern lights. Today, we're going to take a look at how to visualize data, how to plot data in Matlab. So I'm going to share my screen and we'll go to Matlab. Let me clear all this stuff off. I've been doing too much here. Get rid of everything. Get rid of all the stuff that I had before. Okay. Now, there, I mean, completely clean. Now what we're going to do is we're going to import my file, the zombie temperature. So I just can arrow up through my latest commands and find my import statement. I can put this, of course, in a script, but I'm doing it at the command line just for this tutorial. And I'm just going to read in the file zombie_cooling.xlsx, and there I've got it. Okay, so I've got data and I've got labels. Okay, just like we have the last couple times. So now what we're going to do is we're going to enter in the most common visual display. So the very first visual display, let me call out temperature. Let's call these out as separate variables. It makes it a little cleaner when we use our commands. So let's say time equals data 1, okay, column 1 from data, and temperature equals data column 2. Okay. If you don't remember how to do this, that was in the last video. So now what we're going to do is let's just find out what the shape of our temperature data is. We'll do let's do a box plot. Box plot of our temperature data. Okay, so Matlab thought a little bit, and I can look at the figure, and we can see that our our temperature varies, right, from a low of a little below 63, okay, to a high of 65.4 or so. Okay, maybe 65 point, yeah, oh, 65 point, yeah, about 65.4. The median, that's the median, that red line, is about 64.2175. So we can say the max is about 65.42. The minimum is about, come here, is it going to show me? Yes. The minimum is about 62.93. Show me my quartiles? Not yet. No. Okay, there we go. The third quartile, the 75th percentile, is about 64.86. The first quartile, the 25th percentile, is 63.61, and the median is, come on, not the lower J's, I want the median. There we go. The 64.2175. So Matlab allows you to really nicely compare some of these nice robust sample statistics using a box plot. You can stack box plots next to each other. I only have one vector of data, and so my box plot only has one vector, but if I have another vector of data, I can compare them and put them side by side so we can see if one is greater than or less than the other, or one is more spread out than the other. Okay, using the same command. Just separate them by commas. Okay, so now what I can do, let me just keep that graph on. If I want to keep a graph on the screen, I'll put hold on, and that does is holds that graph, and I can now overlay something over top of it. Okay, so if I wanted to overlay, I don't think time's going to look very good, but we can try it. Box plot, instead of temperature, I'm going to put time. Okay, and let's see what it says. And so I've got a little tiny box plot of time because time is on a different scale. Okay. So we can see how, oh, excuse me, this is time here, and temperature is right here, because temperature is only ranged just a little bit. So we can see both of those together, overlaid, okay? All right, if I want to save that figure, I can say, I'll open another figure, a blank figure, and then I can, let's say, put a histogram on. The command for histogram is hist, histogram for temperature, and so it will draw me a histogram. And you can see it's kind of uniform, not a lot of ups and downs, but what I can also do, though, is because I've got enough data, I could say, let's split that into, let's say, 10 bins and see what it looks like. No, it's excuse me, that's the default. Let's split it into 20 bins. And so I can look at figure 2. You can see that's quite a bit different. I could split it into 30 bins. We can see we're not getting a whole lot of extra, resolution. Okay? Let's try something. Let's just do it into a bins of 50. Not getting any extra detail. So I think bins of about 20 are about right. So I'm going to leave it at 20. Look at it again. So you can use this to play around and get the right display of the data just by changing the number of bins. It automatically changes the bin size. Second, what you can do then is I can also do hist fit. And what this will do is overlay a normal distribution, that bell-shaped curve, over top of my data. So I can look at the data. So I can look at the data here, and I can compare it against a box plot. That's not very good. Let's do it. Let's just do another box plot. Box plot. Okay. So I'm making two figures. I've got a box plot and a histogram. And I'm trying to, there we go, pull this down. And then I'm going to go to figure 2, boom, bring those down. So now I can compare them and start to see, yeah, so the lowest is somewhere around 63, okay? The highest is somewhere around 65.5, right about there. And if I fit a normal curve to the data, that's what the normal curve looks like. So I can look at this and say, man, that's much more uniform than a normal distribution. I don't see a big peak in the middle, right? So this is what it should look like if the data were distributed normally. This distribution does not look like that right now, all right? It will give you the heights of any of the bins. Yep, it's going slow because I'm recording this. And it'll give you values of the probability distribution at different points in the probability distribution. This is the for a value of 64 degrees, we get a frequency, expected frequency of about 4.32. So that's not too bad. We actually only got 3. Yeah, so you can compare that with hist fit. And those are the two displays that we use most for univariate data. For bivariate data, we can use scatter to get a scatter plot. And here you have x comma y. So notice x comma y. And so whatever your independent variable is, we'll call that time. And the dependent variable is temperature, okay? And then we can do a scatter plot. And you can see the scatter plot. You can look at it and say, that looks pretty linear. Maybe it's got a little bit of concave up. But it's got looks like things were just heating up when I first put those probes in that zombie. And then it started cooling down. So maybe I've got some error here I need to deal with before I analyze this data. Okay? And so scatter plot. You can also plot things and you get something quite different. Should get something quite different, because you can see these are actual line plots, and so it connects the dots between them, and it gives a. I think it's also plotted something that looks like the line of best fit. Yeah, it looks like it's plotted the line of best fit in the middle. But you can plot those. Okay, you plot these two curves. This connects the dots. Most data are not connected. This one happens to be because it has time. We know that they're connected over time. We know that there's a continuous cooling curve for the data for the probe 2 and for probe 1, and so they can be connected. But most of the time, you'll be using a scatter plot instead of a line graph. And those are the basic graphs that we use. There are others that we will show you later on for specific types of analyses, for factorial analyses and interactions. We'll show you interaction plot. For any regression analysis, we can show you the normal probability plot and the quantile plot. But for almost everything that you're going to do in this class and beyond, you'll just use box plots, histograms, scatter plots, and then, of course, line graphs. Let me go back to the meeting. There we go. And next time we'll start doing some data handling. Take care.